Hello everybody, hope you are doing well. So Dr. Abdul Haq Sinajke here, and we continue with our time series data analysis using EViews. Today we are going to discuss about the TYDL causality methodology, or it's known as Toda, Yamamoto, Dolado, Lütkepohl. So we have explained in previous videos that when we have all of our series are integrated at the same order of I0, then we can use OLS estimation. And when all of our series are integrated of the same order of I1 and they are co-integrated, then we can use Johansen co-integration. And also we have also discussed about ARDL, where we have some of the variables or series are stationary or integrated at I0 and others are integrated or stationary at I1. Here we use ARDL. But in the case where we have some of our variables, or we have a mixture between I0 and I1 and I2, therefore we cannot use ARDL and we cannot use Johansen co-integration. And in this way we can use only TYDL. So what is TYDL? The TYDL causality methodology of Toda and Yamamoto 1995 and Dolado and Lütkepohl 1996 approach enjoys a number of advantages over the alternative. The most two important advantages are TYDL is applicable regardless of the integrated order of the variables data, regardless also of the existence of a configuration between the variables. So the TYDL approach employs a modified wild test M1 with a chi-square distribution for restriction on the parameters of the var k, where k is the appropriate lag length for the var system. The approach also augments the current order k by the maximum order of integration, or we call it dmax. Thus, var k plus dmax is estimated. So, to estimate the TYDL, we have almost 6 or 7 steps, which is easily can be applied in EViews. So the first one, in order to perform the TYDL approach, the first step is to test the integration order of the variables to see if they are I0 or I1 or I2. So the second, let the maximum order of integration of the group of time series be M. So it means that if we have two time series and one found to be I1 and another to be I2, then M equal to maximum, which is 2. If one to be is 0 and another one is to be 1, then the maximum is 1. So M equal to 1. The third step is to set up a var model at levels. Repeat, at levels, irrespective of the order of the integration of the variables. So whatever you find the variables are integrated on 0, I0, I1 or I2, when you set up the var, you set it at levels. The fourth is determining the optimum lag length of the variables based on the usual information criteria such as AIC and SIC. Then the fifth step is to set up the var model with the new lag order of k plus dmax. And the last is the implementation of the non-Granger causality test by employing a standard wall test. So what is the null hypothesis? The null hypothesis is there is Granger non-causality. So if we can reject that null hypothesis, therefore we are supporting the presence of Granger causality. So in order to have Granger causality, then we need to reject the new hypothesis that says that there is a Granger non-causality. So this is an overview and steps that we are going to use. Now we go to the EViews here. So I will go to File, Open, New, Work File. So I use time series as usual, annual from 1971 to 2014. Put OK. I import my data. Import. So the file in desktop. Malaysia data. So I have a list of variables. Now I want to use urban. How urban population, if urban population Granger cause GDP and vice versa. So I take these two. So I want to take the log, the natural log, logarithm. So I come here, generate ln GDP equal log GDP. Then another one, generate ln urban equal log urban. So before we start finding the optimum lag, we have to find the M, or what is the maximum order between these two series. So we have ln GDP and ln urban population, that our constant or our what we are going to find the relationship between them. So I click on first GDP. I come to view, unit test, standard unit test, and I see a level, not stationary. Again, at first difference, stationary. So therefore now we can see that GDP or ln GDP is stationary at first level. So here now we have second, urban, view, unit test, we see a level, not stationary. Again, first difference, not stationary. Now you see the second difference, stationary. So here means that our maximum lag or Dmax is 2, because GDP is 1, urban population is 2. So we take the maximum is 2. So therefore, when now we estimate the VAR, so we have to put our variables, GDP and urban, as -4, because 2 plus 2 equal to 4. So we have to remember that. So the first thing now, I will set up the VAR to check what is the lag. So I will click ln GDP. Here's the dependent variable first, control urban, open as VAR. I keep everything as it is. Okay. I can view lag structure, and I can length criteria. Let me put 12, or let me, okay, so here, how much we have? So based on AIC, it is 12. Based on SC, it is 2. And also based on FPE it is 2, based on LR it is 2. So most of them they say 2, but only HQ and AAC is 12. Let's confirm if these are significant or no. So I come back here, view, lag structure, and I put lag exclusion test. Yeah, it's only lag 1 and lag 2, they are significant. So therefore, my lag length is 2. Okay. I may check for autocorrelation to make sure that there is no autocorrelation. Yes, the probability is more than 0.05. So now I go and estimate the var again. I come to probe, specify estimate again. So here, how much now the lag? We found that the maximum m, the order is 2. Well, this is 2, right? And the optimum lag we decided to be is 2. So 2 plus 2 is 4. Therefore here I write C, then ln GDP. So it must be in level, between bracket minus 4. Then ln urban minus 4. Okay? So here will be 1, 2. Then I press OK. So after that, I will go to view, lag structure again, and put Granger causality block exogeneity test. So now I have this table. Now first we see that urban does not Granger cause GDP at 5%. Probability is 0.07. But at 10%, yes. So here, at 5%, we cannot reject no hypothesis. Therefore, there is Granger no causality. But if we take 10%, we can reject the null hypothesis of that says that there is Granger no causality, and therefore we establish or we confirm that there is Granger causality at 10%. So second, vice versa, if we put urban population as dependent and GDP as independent, then therefore the probability is more than 0.05 and also more than 10%. So here we cannot reject the null hypothesis and we have to accept the null hypothesis. Therefore, there is Granger no causality from GDP to urban. One thing here I would like you to notice that is that in TYDL method, we cannot see the coefficient and the sign of the relationship. So in that way, we will know that there is a long-run relationship or the independent variable Granger caused the dependent variable, but we don't know in which way. So in that case, we would heavily be rely on the theory. So our justification of that relationship or the direction of that relationship of that causality would be based on theoretical background or theoretical base and also maybe on previous empirical studies. I hope that you enjoyed the video and you understand the concept of TYDL. Although it is very simple concept, but it is very interesting and very useful, and it can solve a lot of problems that we face in time series analysis, where we have this series that may stationary at the second difference or second order, and sometimes we may found no co-integration between the series, and we want to see if there is a causality or no. So TYDL is not required for us to find a co-integration, and also some aspect of the VAR problems or limitation of the VAR, applying the VAR on VECM. So this methodology can help a lot in advance our research, and I really encourage you to use it in your studies and in your research. So if you have any question, don't forget to keep your comment below the video. Thank you very much, and I see you in the next video.